Hello everyone, welcome back to lesson 2. In this lesson we are going to complete section 1.1 in the book. Previously we learned how to recognize the general graphs, how to sketch them. Today we study the rest of section 1.1, and by the end of the session we have some real exam questions, some multiple choice questions. You'll get to know how to choose the correct answer. Sometimes we need to solve, sometimes we need to do only some little tests to find the right answer. Sometimes we can do it within a fast way. All of these are to save time and to get the right answer. Let's begin. As the second lesson, today we are going to talk about symmetry. Symmetry has two types. The first type is symmetric with respect to y-axis. Symmetric with respect to y-axis means y-axis cuts the graph into two identical pieces. This type of function is called even. We have two examples for even functions or symmetric with y-axis. If we look at this example, y-axis cuts the graph into two identical pieces. This means this graph is symmetric with respect to y-axis. At the same time, this graph is even. This one is an x power 4. Looks like a W shape. Again, y-axis cuts the graph into two identical pieces, then the function is even. The second type of symmetric function is odd function. Odd function is called symmetric with respect to the origin. If we look at this graph, origin cuts the graph into two identical pieces. The pieces look identical while the origin is the half of the graph. Similarly here, this is a cubic function. Again, origin cuts the graph into two identical pieces. The pieces look alike and origin is in the middle. If we consider y-axis here, y-axis does not cut the graph into two identical pieces. This is why this function is called odd function, or it's called symmetric with respect to the origin. And we have some other functions that are not symmetric. We said symmetric has two types, even and odd. We have some other functions that are not symmetric at all. Then they are not even or odd. On graph, it's easy to recognize even and odd. Always consider an even function like a U shape, and odd function like an S shape. There is an example. Show that the graph of fx equal to 2x cubed minus x is symmetric with respect to the origin. The same question can say, show that this graph is odd. It's the same thing. Then, in order to check for symmetry, we have one replacement. For even and odd, we do the same thing. The replacement is replace every x in the function by negative x. Now this is the function. Each single x should be replaced with negative x. Then rewriting the function with this replacement, f of x becomes f of negative x. 2x cubed is 2 negative x cubed minus, this minus is this minus, and then instead of x we have negative x. Now if we simplify this, negative x power 3 will stay as negative x cubed times 2, negative 2x cubed. Negative negative will be positive. Now in this step we stop. What did we do so far? We replaced each x with negative x and we simplified. Now we compare. We compare this to the original function, which is fx. At this step, we compare. In the comparison, you see that this negative 2x cubed plus x does not look like this. If it does, it means the function is even. After we replace negative x and simplify, if the result is the same as fx, means the function is even. But here I have a result which is not the same as fx. This means this function is not even. But it doesn't mean that it's directly odd. We need to complete. To complete that, To complete that, what we do, after I replace negative x and simplify it, the result does not look like fx. I take one negative as common factor from all the terms. If I take one negative from negative 2x cubed, what's remaining is just 2x cubed. If I take the negative, what's remaining is 2x cubed. This one is positive x. If I take one negative from it, a negative is remaining. Then a negative as common factor is outside. The rest, which is inside this bracket, again compare. Compare to fx. If they look like each other, if they look alike, means the function is odd after taking one negative as common factor. If again they don't look alike with fx, means the function is neither even nor odd, means it's not even and not odd at the same time. Then if we look at this 2x cubed minus x, we are familiar with this. It's right here. A negative is extra. This is fx. This part is fx. And a negative is extra. That's negative fx. Then since I had fx is equal to f of negative x is equal to negative fx, since f of negative x is equal to negative fx, the function is odd. We are doing the same steps for every question. Replace each x with negative x, simplify, compare the result to fx. If they look alike, means the function is even. If no, take one negative as common factor from all the terms, then the resulting expression, compare it to fx again. If they are equal and there is an extra negative outside, means the function is odd. If they are not equal again, means the function is neither even nor odd. Here are some notes and fast ways about even and odd functions, how to recognize them. These are good for multiple choice. First, a function is even if all the terms of the function have even powers. Like this one. It has x power 4, you know 4 is even. It has, the 7 doesn't affect. X power 2, you know 2 is even. And this one is just constant. Constant function is always even. Fx equal to a number is always even. It doesn't matter. The number is even, the number is odd, the number is positive, negative, 0. Fx equal to a single number, as function, it's always even. Now I have a combination of even functions. This is even, this is even, this is even, means all of them together as fx is also even. Similarly, if all the terms have odd powers, like x power 5, 2x power 3, x has no power means power 1, as 1 is odd, 3 is odd, 5 is odd, then fx as combination of odd functions is also odd. We said constant function is always even. There's another thing about even and odd functions. If a point xy is on the graph of an even function, then the point negative xy is also on the graph. Let's explain this. I'm going to draw a little graph here. We said consider even function as this. Always when you think about even function, consider the graph is like this. Then the point xy, the x and the y are both positive, is this point. Since the function is even, this point is xy. Since the function is even, there is another point. If x is positive here, then this is negative x. And if we look at the 2 points, they have the same y, then the y doesn't change. This is negative x, y. So for even functions, only the sign of x changes when you work on points. If xy is a point on an even function, then negative xy is also a point on that even function. If 1, 2 is a point on an even function, then negative 1, 2 is also a point on that even function. For odd function, If a point xy is an odd functions graph, then the point negative x, negative y. For odd functions, both signs change. The sign of x, the sign of y together, both of them change. Here, they are both positive. In the reflection, they are both negative. I said consider the graph of odd function as S. Then when there is an xy axis like this to represent this, this is an odd graph. On this odd graph, if I say this point is xy, if xy is here, x is positive, y is positive as well. What could this point be? Isn't it negative x, negative y? Then as point, this is negative x, negative y. That was on graph. Number 6 is an important one. If you have addition, subtraction of some even functions, just like the point number 1, you have some even functions added or subtracted together, all of them together as a function is even. If you have some odd functions added or subtracted together, all of them together as one function is odd. But if you have odd and even mixed, and between them is plus and minus, this function is neither even nor odd. Number 7, sine and tan are both odd trigonometric functions, whilst cosine is always even. Number 8, in multiplication and division, two even functions or two odd functions is always even. If you multiply two even functions together, two odd functions together, the resulting function is always even. Here, in multiplication and division of different functions, like even multiply by odd multiply by even divide by odd divide by even, in multiplication and division of different functions, even, odd, the resulting function is always odd. We will have exercises later, and we have some quick examples here. This function is even. This one is even. This one is also even. Even plus even is even. That's right. Even plus even, the denominator is even. This even power makes this function even. Then even divide by even, the result is even. This one, sine is odd. X cubed minus x power 1 is also odd. Odd divide by odd is even. Here, this function is even. X squared is even. 1 is even. X squared plus 1 altogether is even. X power 1 is odd. Odd divide by even, or even divide by odd. All of them together as one function is odd. Now we have some exercise from the book. In exercise 15 to 20, determine whether the function is symmetric with respect to y-axis or symmetric with respect to the origin. Symmetric with y-axis means even. Symmetric with the origin means odd. Now let's solve this. This is even. X power 2 is even. Number is even. So even minus even is even. This is even. If I want to use the algebraic way to show that, first, f of negative x means replace each single x with negative x, will be negative x all squared. Don't forget to use brackets for every negative term or number, minus 2. 2 has no x, then this negative doesn't affect 2. Now we know power 2 cancels negative. Negative x power 2 is x squared minus x. Compare, do we have the same fx? Yes, we do. Then since f of negative x is equal to fx, the function is even. This one, we said if even and odd are mixed with multiplication with if even and odd are mixed with subtraction and addition. The resulting function is neither even nor odd. But if they are mixed with multiplication, even times odd will be odd, even divide odd will be odd. Now this one is neither, because this term is even, this term is odd. If we subtract them, it's none of them. It's not even, not odd, so we say it's neither of them. 17, 4 is just a number which is considered even. X power 1 is odd, then even divided by odd is odd. If I use algebraic way to show that, f of negative x is equal to 4 over negative x. Then there is nothing to cancel this negative. The negative remains, negative 4 over x. Now if we compare, this part looks like fx, and there is an extra negative outside. This means f of negative x is equal to negative fx. This means odd. This is the definition of odd. We have more exercise. Here, this is the graph of a semicircle. And semicircle is a symmetric graph. Semicircle if this is an xy axis, semicircle is even because y-axis cuts the graph of semicircle into two identical pieces. Means the numerator is even. The denominator is odd, so even divided by odd will be odd. This is the fast way. Here, these are odd. There is a note. Absolute value function is even. Then this is an odd function, but it's surrounded by even. This makes the result even. It makes the graph look like a V shape, and the V shape has y-axis in the middle. This one, this part is even because it's just a number. This part is odd plus even combined. This part is none, not even nor odd. Then even minus none, the result will be neither as well. It's not even, not odd. Because of this, here we have even part plus odd part. X is odd, number 3 is even, then odd plus even is always neither. That was enough about even and odd functions. We will have more examples later, more exercises. Now let's learn about points of intersection between two graphs. If we have two graphs, they intersect at some points. How can we find these points without the graph? Then there is one easy step we should follow, which is if we have two functions, f and g, and we want to find points of intersection. The first and the easiest step is to equate them. Fx equal to gx. Then solve. Let's see this. This is fx, x squared minus 3. This is gx, x minus 1. Then we just put an equal between them. Then solve this. X's to one side, numbers to one side, if all the x's are power 1. If there is x power 2, try to make a quadratic equation equal to 0, then we make two brackets. Look at this. X cubed minus 3 is f, x minus 1 is g. Now, these should go to the other side, x minus 1. This x becomes negative x, minus 1 becomes plus 1. Now let's simplify. X squared has no like term to be simplified with, it stays the same. Minus x stays the same. Minus 3 plus 1 is minus 2. Now, before I told you recognize this quadratic function, because it's very common in the book, we need to make this two brackets. We need to factorize. To factorize this, we need two numbers. When we multiply, we get -2. So we can say 1 times -2. The result is -2. But these two numbers, if I add them, I should get -1. There is -1, and there is -2. I should get this one from multiplication, this one from addition. Now, 1 times -2 is -2. 1 plus -2 is -1. So I'm going to choose these two numbers, 1 and -2, in the brackets because they are satisfying the equation. Here, -2 goes into a bracket that makes x minus 2. +1 goes into the other bracket that makes x plus 1. We studied zero product. We have two brackets multiplied by each other. The result is 0. This means if this bracket is 0, if x minus 2 is 0, then x is 2. This is the 2. If x plus 1 is 0, x plus 1 is 0, that makes x equal to -1. This is the other x. Now we found two answers. This means this graph and this graph, they intersect at two different points. Now these are the x's. To make these points, we need to find y's for them. Look at the two functions. Which one is easier? G is easier. So I'm going to use G to find the y for each point. When x is 2, 2 goes into function g. G of 2 is 2 minus 1. 2 minus 1 is 1. So the y for 2 is 1. As point, it will be 2, 1. And g of -1, when x is -1, we should find g of -1. That is x minus 1 will be -1 minus 1, which is -2. Then as point, it will be -1, -2. The first point was 2, 1. Now if we look at the graphs, this is the graph of f. This is the graph of f. This is the graph of g. They intersect at 2 points. One point is 2, 1. This is 2, 1. And the other point is -1, -2. So we found the points without the graph. This is what we do. Make the two equations equal, then solve to find the value of x. Then later, which function is easier, use it to find the y to make the points. This is a check it out from the book. Find the points of intersection of the graphs of the function. X cubed minus x is fx, and gx is 1 over 4 x squared minus 1. Solution. Let's do this. Step 1, always equate them. X cubed minus x equal to 1 over 4 x squared minus 1. Then here in this part, we can take x as common factor. Recognize this as well. Whenever you see x cubed minus x or minus x squared, there is x, there is x, we can take 1x as common factor. If we take 1x from this part, x cubed will be x squared. This one is x. If we take x from it, only 1 is remaining, and the minus is as it is. Now, this part became this. Then these should go to the other side. Why I do this? Because there is x power 2. Then since there is x power 2, I should make one side of the equation 0. If there is only x without power 2, I should go with x's to one side, numbers to one side. Now I should make one side 0. This 1 over 4x squared minus 1 goes to the other side. The entire thing becomes negative. Negative 1 over 4x squared minus 1. Now, if we look at this, x minus 1 is common factor again. Let's clarify this. Now, when this goes to the other side, we have x squared minus 1, x squared minus 1. I can take x squared minus 1 from each term. If I take x squared minus 1 from this side, what's remaining is only x. If I take x squared minus 1 from this side, what's remaining is negative 1 over 4. Then x squared minus 1 is the common part. Now the zero product again appeared. I have this bracket multiplied by this bracket. The result is 0. X squared minus 1, this will be difference between two squares. It will be two brackets. X minus 1, x plus 1. This is 0 at 1. This is 0 at negative 1. This is why x squared minus 1 equal to 0 has two solutions. Or this part is 0. X minus 1 over 4 is 0. That makes x 1 over 4 because 1 over 4 minus 1 over 4 is 0. Then I have three values for x. 1 and negative 1 and 1 over 4 or 0.25, doesn't matter. Now I have the three x values where the two graphs intersect. To make these points, which function is easier? Which one you think is easier? Use it to make these x's into the function. Find y for each one to make the points. Find the points of intersection between fx equal to 3 minus x under square root, gx equal to x minus 1. Here it says point, s is between two brackets, because there could be one point, there could be more than one point. This is why this s is here, because there could be more than one point of intersection, or there could be only one point of intersection. The way we do it, we substitute the choices into the functions. The correct answer, the correct choice, should make both equations equal. Then let's go with a, x equal to negative 1. I'm going to write negative 1 in f, then negative 1 in g. The two results should be equal if a is the correct answer. Let's go with this. F of negative 1 is 3 minus negative 1, which is 3 plus 1. 3 plus 1 is 4. Square root of 4, 2. G of negative 1 is x minus 1, which is negative 1 minus 1, that's negative 2. The two answers are not equal. This means A is not the correct answer. Now, A is out in the competition. It's not the correct answer. Let's go with B. B, x is 2. Then let's replace 2 here. 3 minus 2. 3 minus 2 is 1. Square root of 1 is still 1. Here, x is 2. 2 minus 1 is 1. Then the two answers I got from F and G are equal. This means B could be the correct answer. Now looking at the other choices, this one says both. Both means A and B. Since we are sure that A is wrong, then both is also wrong. And we have a correct answer, that is B. None is also not the correct choice. The final answer is B, because it made both functions F and G equal. In exercise 21 to 24, find the points of intersection for the two graphs. Then 21 is very easy. You just have to write 2 minus x equal to 2x minus 1. All the x's have power 1. Then x's to one side, numbers to one side. Within 2 steps, you can find it. 22, there is x power 2 in it, and this one is x power 1. Anyways, we equate them. 6 minus x squared equal to 4 minus x. Now there is a note. If we look at the highest power of x, which is x power 2, is negative. We should not have this negative while solving to make the solving process easier. Then this side, I'll send them to this side. The signs change. Negative x squared becomes positive x squared. Now, 4 minus x as they are. 6, this 6 is positive. It became negative 6. Negative x squared is plus x squared. 4 minus 6 is negative 2. X squared is alone, and negative x is here. Again, we have the quadratic equation. To factorize this, we need two numbers. When we multiply these two numbers, the result is -2. When we add these two numbers, the result is -1. These two numbers are -2 and 1. -2 times 1, -2. -2 plus 1, -1. Then I'm going to go with the two numbers, -2, +1 in the brackets. This is why I have x minus 2, x plus 1. X minus 2 is equal to 0 if x is 2, because 2 minus 2 is 0. X plus 1 is equal to 0 if x is -1, because -1 plus 1 is 0. Now I have two x values. Function g is easier. Put 2 here. 4 minus 2 is 2. So when x is 2, y is also 2. The point 2, 2 is one point of intersection between the two graphs. When x is -1, -1 goes there. 4 minus -1 is 5. So the point -1, 5 is the other point of intersection between the two graphs f and g. We have them. 2, 2, -1, 5. Now let's solve some problem related to absolute value. Absolute value is slightly different from the other types of functions because when we want to solve something with absolute value, we will always consider two cases. Let's look at this example. Find the points of intersection between fx equal to absolute value 2x plus 4, gx equal to -x plus 1. Now, in order to find points of intersection, I just have to equate the two functions. First function, the absolute value, equal to the second function. Now, when you want to solve some absolute value problem, if there are numbers or other things like x, if I have something like this, I should get rid of all of these. Like this x goes to the other side, becomes -x, this -2, divide everything by -2. Why I do this? To have the absolute value all alone on one side. When I have this, then I'll follow the two cases. The two cases are like this. The absolute value sign will go to x plus 4 is either equal to -x plus 1 or it's equal to the negative of -x plus 1. These are the two cases. One case is the function as it is. The other case is negative bracket the function. Now I have two separate equations to solve. I solve each one separately. From each one I get one answer or two answers or no point of intersection. It's fine. Now let's continue. I had one single absolute value on one side, another expression on the other side. Then 2x plus 4 without absolute value, once is equal to this as it is, once it's equal to negative, then the function -x plus 1. Now solving this, all the x's have power 1, then x's to one side, numbers to one side. -x goes to the other side, becomes +x. 2x plus x, that's 3x. +4 becomes -4. 1 minus 4 is -3. Then divide 3, x equal to -1. When x is -1, the function g is easier, which is -x plus 1. This -x goes in place of x. Then -1 will be 1 plus 1 is 2. Then the point -1, 2 is one point of intersection between the absolute value and the linear function. The other part, again, 2x plus 4 without absolute value equal to one big negative and the function. This should be expanded. -x times negative is +x. +1 times this negative is -1. Then again, all the x's I have, they are power 1. Then x's to one side, numbers to one side. This +x goes to the other side, becomes -x. 2x minus x is just x. -1 minus 4 is -5. Now, this is the x. Again, the function g is easier. I'm going to write this in place of x in g. that makes negative 5 plus 1. Negative is positive, plus 1, that is 6. The point negative 5, 6 is the other point of intersection between this absolute value and this linear function. We have more exercises from the book. Question 23, I have cubic and quadratic. Let's look at this. To find points of intersection between two graphs or between two functions, firstly we equate them. Then this function, x cubed minus 2x squared plus x minus 1 equal to negative x squared plus 3x minus 1. Now after I equate them, since I don't have all the x's power 1, then I should make one side of the equation 0. Then these all move to the other side. When they move to the other side, negative x squared becomes positive x squared. Positive 3x becomes negative 3x. Negative 1 becomes positive 1. Now let's simplify x squares together, x's together, numbers together. X cubed is alone, there is no any other x cubed to be simplified with, so we just write this down. Negative 2x squared and 1x squared together, that will be like negative 2 plus 1, which is negative 1. This is why we have negative x squared remaining. This is positive x, this is negative 3x. Negative 3 plus 1 is negative 2, equal to 0. For cubic functions, when you see x, take one x as common factor. Then if I take one x from x cubed, x squared remaining. Take one x from x power 2, x power 1 remaining. Take one x from 2x, only 2 is remaining. Now I have 0 product. X multiplied by this quadratic, the result is 0. So either x is 0 or this quadratic is 0. This quadratic, we need to factorize it to two brackets. Again, we go with x plus 1, x minus 2, because we need two numbers. When you multiply, you get negative 2. When you add them, we get negative 1. That is negative 2 times 1, negative 2 plus 1. Then in the brackets, I'm going to use negative 2, positive 1. This is why there is x plus 1, x minus 2. Result is still 0. Result is 0. Then I have three terms multiplied by each other equal to 0. Then either x is 0, or if x plus 1 is 0, x is negative 1, because negative 1 plus 1 is 0. X minus 2 is 0, x is 2, because 2 minus 2 is 0. Now I have three x values. The two functions I have, which one you think is easier? We replace x with 0. The result is negative 1. We replace x with negative 1. The result is negative 5. That's the point. Replace x with 2 in g. The result is 1. So 0, negative 1 is one point of intersection. Negative 1, negative 5 is the other point of intersection. 2, 1 is the third point of intersection between this cubic and quadratic graphs. This one is absolute value. Now I'm sure you can do it. Let me simplify the equation and the solving for you. Negative absolute value 2x minus 3 plus 6 equal to 6 minus x. This is step 1. Since there is absolute value, this absolute value should be completely alone on one side. Then this 6 should go to the other side in order to have the absolute value alone. Negative 2x minus 3 equal to 6 minus x minus 6. Then 6 cancels 6. What's remaining is only negative x on the side. On the other side, we have negative absolute value 2x minus 3. The absolute value is still not alone because of this negative. Then I multiply everything by negative 1. When I multiply, this negative will be cancelled and this negative will be cancelled. That is 2x minus 3 equal to x. Then this will be two cases. One case 2x minus 3 equal x, and the other case 2x minus 3 equal negative x. Then by solving each one, we will get one point of intersection. Then there are 2 points of intersection between this absolute value and this linear function. You can complete, it's easy. X goes to the other side, then negative 3 to the other side, divide by 2. Okay. In exercise 28 to 31, determine whether it's true or false. If 1, negative 2 is a point on the symmetric graph with respect to the origin. Symmetric with respect to the origin means we consider the graph as an S shape because respect to the origin is odd function. Then let's demonstrate that. Now, the point 1, negative 2, the graph is the opposite. It's still odd. The point 1, negative 2 is here. The other point should be negative 1, positive 2. Do we have that? No, we don't. In odd functions, both signs change. This is 1, negative 2. Then the other point that is on the graph should be negative 1, positive 2. Both signs should change, negative to positive, positive to negative. But here, if we look at the negative 2 is the same in both points, then of course this point does not belong to an odd function. Then this 28 is false. The example, the anti-example is this point could be negative 1, 2. Not negative 1, negative 2. 29, if 1, negative 2 is a point on a graph symmetric with respect to y-axis means even, then negative 1, negative 2 is also a point. Let's see. If 1, negative 2 is a point on the graph, then the other point should be negative 1, negative 2. If this is 1, negative 2, the other point, the partner should be negative 1, negative 2. Do we have this? Yes, we do. Then 29 is true. In even functions, only the sign of x changes. The y doesn't change. This x is positive 1. The other x should be negative 1. Y should be the same for both of them. This is how even functions work. Now we have a note about discriminant. This part, b squared minus 4ac, b squared minus 4ac is from quadratic formula. If b squared minus 4ac is greater than 0, then the graph ax squared plus bx plus c has only 2x intercepts. This is correct. This is true. And we have other notes about it. If b squared minus 4ac is more than 0, then there are two solutions. If b squared minus 4ac is equal to 0, there is only one solution. If b squared minus 4ac is less than 0, there is no solution. There is no solution means there is no x-intercept, means there is no place that the equation crosses x-axis. To memorize these fast, b squared minus 4ac greater than 0 is 2, equal to 0 is 1, less than 0 is no solution. The only greater number is 2, equal 0, one solution or one x-intercept, less than 0, no solution or no x-intercept. Find the equation of a graph that consists of all points x, y whose distance to the origin is double their distance to the point 0, 3. This is an important question and it's been in the real exam several times. The first thing we need to know, go back to grade 10 and 11, the rule, distance between 2 points. This rule is distance between 2 points. The rule is like this. The 2 points we have, each point is x1, y1, x2, y2. Then x2 minus x1 squared plus y2 minus y1 squared, all under square root. That is distance between 2 points. Now the 2 points I have, one of them is clear, 0, 3. The other one is not clear, xy. So it's missing. Then we have clue that the distance is double, means the distance between the points we want to find to the origin, which is 0, 0, is double the distance of xy to this. Then let's write the points xy, 0, 3 and 0, 0 into the distance between 2 points rule. Then what we have, x minus 0 squared plus y minus 0 squared, this is the distance between this point and the point 0, 0. 0, 0 is the origin. When the question says origin, means 0, 0. Then x minus 0 squared plus y minus 0 squared, this is distance between these 2 points. This distance is half of the other distance, x minus 0 squared plus y minus 3 squared. Now I have an equation that has square root in it. To remove square root, I can simply square both sides, power 2 both sides, then the square roots will be cancelled. Now x minus 0, let's add a step between these two to make it clearer. X minus 0 is just x. The power 2 goes for the x, that's x power 2. Y minus 0 is just y, with this power 2 is y squared. Between the two brackets is plus, this is plus, and square root, equal to 2 times, again square root, x minus 0 is x power 2, y minus 3 plus y minus 3 power 2. Now I have this. To solve this, square both sides, then this will go. This will be 2 power 2, this will go. 2 power 2 is 4, then we get to this step. X squared plus y squared without root, equal, between them is equal. 2 power 2 is 4, and this one has no root again. Then, in order to solve this, I have a bracket to expand. So, to expand a bracket with power 2, there are 2 ways. One way is to write the bracket twice, y minus 3 multiplied by y minus 3. The other way is, as I say, first term squared, y will be y power 2, 2 times first times second, 2 times y to y, times negative 3, negative 6y. The second term squared, negative 3 squared, 9. Now I have the square bracket expanded. This 4 is still here. And for the x squared, the 4 will get the x squared. Now, on this side, I have more terms. Let's send these to the other side. When I send them to the other side, they both become negative, and one side of the equation will be 0. There is no difference between writing 0 here, 0 equal to some terms, or write 0 on the other side. For simplicity, 0 on this side is better. Now negative x squared minus y squared plus 4x squared, 4 times x squared is this, and 4 times this will be 4 times x squared minus 6x plus 9. Now I'll simplify x squares together, y squares together, and numbers together. Then this is 4x squared with negative x squared, that will be 3x squared. This is 4y squared with negative y squared will be 3y squared. 4 times negative 6 is negative 24. 4 times 9 is 36, equal to 0. If we look at the question, it says find the equation. This is the equation. We cannot solve this equation for now because we have two unknowns, x and y. Then don't spend time trying to solve equations with two unknowns, because we can't. We cannot solve one equation that has two unknowns. Later we study some other cases that we can solve equation with two unknown, but we should have two equations. Then we will solve them simultaneously. These questions are from the end of chapter and the study guide of chapter 1. We solved similar questions. This question has an idea in it that's a little bit different from what we solved so far. Find the intercepts. Intercepts mean x-intercept and y-intercept for each function. Then tell if the function is symmetric with respect to y-axis or with respect to the origin. So we have to do two things. Firstly, we need to find the intercepts. Then we need to tell if the function is even or odd. Now, let's do part A. fx equal to x over absolute value x plus 1. Now to find x-intercept, y should be 0. Then y is fx, x over absolute value x plus 1 equal to 0. For solving fractions, we only solve numerator when it's equal to 0. Then the numerator luckily is just x, so x equal to 0. This is one solution for the x-intercept. When x is 0, then if we go back and put 0 in place of x, this will be 0, 0 plus 1, the result will be 0 over 1. That is okay, it's not undefined, it's defined. And we know y is 0, and the point x-intercept is 0, 0. We know if x-intercept is 0, 0, there should be a y-intercept as well as 0, 0. To find y-intercept, we'll replace x with 0 as I already did, or let's try it. Absolute value 0 plus 1. That is each x replaced with 0. The result is 0 over 1, which is 0. Then the point 0, 0 is y-intercept as well. The x-intercept and the y-intercept are the same point. It's just one point. Then to tell if the function is even or odd, we go back to the quick note. X alone is odd. Absolute value is even. Number alone is even. Then this denominator altogether is even. Odd divided by even makes the graph odd. This is the end of this session. Thank you so much for watching. Stay tuned to see the other sessions. Bye.
گروپی لاس بۆ فۆتۆکۆپی و پەڕەوگا لە خزمەتی قوتابیانی خۆشەویستدایە بۆ ئەوەی لە وەرزی نوێی خوێندن ماندوو نەبن ئێمە هەموو پێداویستەکانی قوتاب